APBC calculus students. This video is about differential equations and Euler's approximation. So far we have seen what is a differential equation. Differential equation is an equation which involves derivatives. Then we saw that sometimes you can solve it or sometimes you cannot solve. If you solve, you must separate the variables. If you cannot separate the variables, then you got to do something. Now, what types of differential equations we have seen so far? So let's talk about a few different types of differential equations we have seen. One is exponential differential equations, where rate of change is proportional to the quantity itself. The second one is a logistic differential equation, where rate of change is dependent on quantity itself and what you don't have, what you have and what you don't have. This is dp dt is k times p. Now there are many other differential equations also which are not exponential, which are not logistic. You are expected to solve them as well. They could be parabola or any polynomial or log or any kind of, those are comes in other differential equations. You must know the difference between them. Difference between them means you must know the difference between them. They have to, you cannot solve logistic differential equations. You are not expected to know that how to solve logistic differential equation. So let's talk about the approximation. Approximation is slope field, which we have already covered. Slope field to differential equation matching and solution equation matching, which are most of the time multiple choice questions. We already know that. We already covered that. So today's topic is about Euler's. So first thing you should know how you pronounce. It's not a Euler, but it's Euler's approximation. Approximation is a huge deal in BC calculus. Anytime you use an approximation, that means you approximate the value. The question is it over approximation or under approximation? So I'm going to quick review about here is in the first semester, we learned that concavity and equation of tangent line. If the graph is concave up, the tangent line is below, it is under approximation. If graph is concave down, tangent line is above, and this is overestimation or over approximation. So we are going to use this topic from the first semester as well. Then you must know all the properties of logistic. You must know all the properties of logistic differential equations. Where is the carrying capacity? When is the maximum rate of growth occurs? But it is not expected that you solve differential equation. Sometimes they are in disguise. You can't even identify them. We need to rewrite to identify those logistic differential equation. So this video is about Euler. So let's talk about the Euler. Now, before I jump into the calculus part of the Euler, let's see something about Euler. I always say that you have to pay respect to this genius mathematician who came up with so many things. So let's pay respect and say his name correct way. So it is Euler. You pronounce it just like oil, but Euler. So it's so interesting that function notation, his contribution, E, his contribution, you might see that connection with the E and first letter of that. Interesting that is he was half blind or totally half blind, totally blind when he came up with all this. Contribution to pi, I, summation notation, and this is the time frame, 1707 to 1783. His biggest contribution is the most beautiful equation. We call them e to the I pi. This is called Euler's identity. E to the I pi plus 1 is a 0, where basic arithmetic operations occur exactly once: addition, multiplication, exponential, and these are the 5 numbers being used: 0, 1, I, pi, and e. So this equation is called the most beautiful equation ever come up in mathematics. As a BC calculus student, you should know this equation. And later on, maybe we can prove this in a series unit. So this is Euler's contribution. Now let's come back to the topic, what we have to know. This is your page number 29. Now, one thing I would confess that in the packet, the notes are a little bit different than my flip chart here, but the questions are same. It looks different, but the questions are same. I'm going to skip this warm-up about solving the differential equation because I want to keep this video shorter and I want to focus on Euler's method. So if we cannot solve, we can approximate. How do we approximate? So what is Euler's method is? Euler's method is finding equation of tangent line multiple times. You find equation of tangent line at one step and then you find it again. So it's called multiple repeated process, and it's like walking along the tightrope. So let me show you on the picture here on this. So if we start from here and we have a slope equations and we have initial point, so we find the equation of tangent line, we take a one stop, then we stop here again, we try to find the another equation of tangent line, and then we use it to go further. So in other words, we are just trying to bend this line. We are trying to bend this line. Now line cannot be bent, so we are just jumping on to another line. From here to here, we jump onto another line, and then we jump onto one more line. So depending on how far you are going, we are just finding equation of tangent line multiple times. So we say again, it's a very repetitive process, but simple, easy and repetitive. I would say it's much easier demonstrated with an example rather than complicated formula. So I would like to jump straight to the example. One thing you have to know that differential equation is you are given a dy dx, which is nothing but the slope. Sometimes they give you f prime of x, which is also nothing but the slope. So what multiple steps are involved is, I'm just explaining here, we know that y minus y1 is equal to mx minus x1. We use solve for y, so we can say y1 plus mx minus x1. We use this equation to approximate the next value. So let's make a connection. M is nothing but f prime of x, and x minus x1 is nothing but delta x. And we have this y1. So we always say this new y value is old y value. I have this is the old one plus f prime of x times delta x. New y is old y plus slope times delta x. So let's jump onto the next page where you are allowed to use a table. You are allowed to use a table. And I prefer that the table is helping you so much to organize all those values. So memorize this chart, and yes, in AP exam, it is allowed to use the table. Now, this topic is very important for the AP exam as well. You are always, there is a question about Euler, whether it is a multiple choice question or it could be free response question. So x and y, you are always given a 1 point to begin with. You are always given a slope. So this is the equation. Let me explain here in this example. Okay, so first of all, let's make a connection. This is my slope equation, is x minus 2. You are given that initial point 0 is 1. So your initial point x and y is 0 and 1. You have to find the approximation of y of 2. You have to find the approximation of y of 2. That means you are starting at 0, but you have to jump to the 2. You have to use Euler's method and 2 equal steps. You have to take 2 equal steps. So pretend that you are at 0 and you have to approximate at 2. You have to take 2 steps. So what will be my length of the step? That's what you have to understand. The dx is the length of the step. So I'm just writing dy. This is a preliminary work. Dy is equal to, let me try to rewrite. Dy is equal to x minus 2 times dx. You are at 0, you have to go to 2, which means I have to, number of steps are 2. Number of steps are 2, and my delta x will be 2 minus 0 over 2. That means my step size is 1. My step size, sometimes it's very obvious, but I'm just still showing you the process here, that delta x dx is a 1. Delta x is a dx, the step size is a 1. So now let's make the table. X, y, dy is equal to x minus 2 times dx, and this is your new y value. Okay, so you are given 0 and 1. Your starting value is 0, 1. That's what you begin with. Dy is, you are substituting here. X is a 0, 0 minus 2. Dx is a 1. So you can substitute here. This equation will be x minus 2 times 1 because dx is 1. So times 1. This number is negative 2. Right? So what will be my new y? New y is 1 plus negative 2. New y will be my y1. If you recall, my equation is y is equal to y1 plus m x minus x1. We did it on the other side, remember? So this is m is a f prime, and this is delta x and y1. So this is my, I'm just bringing the information from the other side. So this is f prime or dy times dx. So new y is negative 1. So I came up to here. My new y will be, what's my new step? I started here is 0 and 1. Now when x is 1, because my step size is 1, so this is my dx, I go to the next step. My step size is 1. My coordinates are 1 and negative 1. That means my new step is 1 and negative 1. I'm just showing you the coordinates here, not necessarily to the scale that I started at 0, 1. I use the same slope formula, and my next step is I'm at 0, negative 1. So now this is your new step, new value. This is you start from scratch again. This is your new value. Slope is still same equation. So let's substitute x value here. 1 minus 2 times 1. This will give me negative 1. So what's your new y value will be old y plus a new y. So negative 1 plus negative 1. This is negative 2. So let's copy that equation. Copy that, bring down that value here. This is 2, negative 2. And this is where you stop. I prefer to write stop because sometimes students keep going. So what is my y of 2 is negative 2. Y of 2, you always declare the answer. Now this is an approximation. This is an approximation. Now some of you says, can't we solve this equation and then get y of 2? Yes, we can. But we are introducing Euler's approximation. And that's the reason I chose the easiest example here to show you. So this is f of 2 is negative 2. I'm putting a squiggly line to show that that's the approximation. So solve the differential equation and with the same initial condition and use it to approximate y of 2. So let's try to solve this differential equation. dy is equal to x minus 2 dx. Y is equal to x square over 2 minus 2x plus c. We are given y of 0 is a 1. So this will give me 1 equal to 0 minus 0 plus c. C is 1. So what's my actual equation is y is equal to x square over 2 minus 2x plus 1. This is the actual equation, solution. This is the solution equation. Solution equation. Because this can be solvable, that's why we wrote it. Now, using this equation, if we find y of 2, I can say 4 divided by 2, 2 times 2 plus 1, and we get negative 1 answer. This is equal to, this is the actual solution. We got it negative 1. Okay, so then it talks about the error. The error in using Euler's method is the difference between approximate value and exact value. So we are, like you can see that we are heading towards the BC calculus part, and the series unit is also about the error and approximation. So anytime you are looking at the error, know that this is the first time we are finding error. We are going to do it several times in the next maybe couple of units. Error is always absolute value. Error is always difference. Actual value minus approximation. Now, since it is absolute value, does not matter which one comes first. Error is always a difference, and it's always absolute value. So in this case, we can say that error is negative 2 minus negative 1. Doesn't matter, positive, negative, I mean, which one you wrote. Now I have to, let me write the other way around. You will see the difference is still same. Okay, so negative 1 minus negative 2, error is 1. Error is 1. So it says, what's the error in your answer? So error is 1. Now, how could you produce smaller error? The smaller error, to produce a smaller error, use a smaller step size. Smaller step size. Use a smaller step size, just like our Riemann sum. Use a smaller step size means delta x is very small number. You take a smaller step. Then if you take a smaller steps, then of course you will have to take so many steps to go to the 2. You start at 0, you go to the 2. In this case, we took 2 steps. So usually they tell you how many steps to take. 2 steps. So if we have to take 2 steps, then of course the step size is 1, but then we have a huge error. So how do we get a smaller error? Smaller error means take a smaller step size, then you will have a better approximation. Let's take a look at another example here. Another example here, use Euler's method to approximate solution to the differential equation. Now notice that they gave you f prime of x. So this is a differential equation passing through 0 point. This is your initial value to begin with. Two equal steps. So now good thing is they always tell you to take equal steps. It's not, you will never see that one step is a smaller and the other one is a bigger. No, they are always equal steps. To approximate y of 0.2. So remember, this is my x value and this is a x value. So you are starting at 0. You have to go to the 0.2. So what will be your step size? So I'm just beginning x minus y times dx. You must find dx. So x equal to 0 to 0.2. X equal to 0 to x equal to 0.2 in a 2 steps. So my dx, which is delta x, is 0.1. 0.1. 2 steps means dx is 0.1. Now notice sometimes you are going forward, sometimes you are going backward. If you are going backward, then your dx will be negative. There are a couple of examples where you start with 0, but you are approximating on the left side. If you are approximating on the left side, your dx will be negative. Okay, so let's start with the table. And yes, you have to, part of this requirement is header must be there. You must show the header of the table. You cannot just write the number straight away. You have to show the header, and this is your new y value. College Board accepts the table with the header. I will show you. If you don't want to show the table, you will have to show two different equations, two step equations. So you start with 0 and 1. dy is x minus y times 0.1. So x and y is substitute 0 minus y times 0.1, which will give me negative 0.1. New y is the sum of these two column is your new y. So 1 minus 0.1. That's my new y, which is 0.9. So my new step, now what do I write here? Remember, the step size is 0.1. So this is my step 0.1. And if you want, you can write up front ahead that this is what you are looking for. You started at 0. This is your step size. This is your 2 steps, step number 1, step number 2. Okay, so now my first step, my y value is 0.9. Now repeat the process again. Repeat the process again. I'm just clearing this so that it looks neat and clean. Okay, so now I have to start the process again. X minus y. So this is my x minus y. I would not recommend that you do the math in your head. Just show the work, because sometimes it's too easy. We are easily making mistakes. So this is 0.1. My new y is the sum of these two. Like I said, we learn calculus, but we make a mistake. So my new y is 0.9 plus, just like Riemann sum, you do not have to simplify. I'm just writing 0.1 minus 0.9 times 0.1. This is my answer. So fy. You have to declare the answer. Y of 0.2 is equal to 0.9 plus, I know I can't resist that, 0.8 times 0.1. This is your approximation. Do not simplify, do not add, do not do anything. Rubric for AP exam is, you get the first step correct, you get the 1 point, second step, second point. This is free response question is not more than 2 points. You must declare the answer. Do not circle here. You must show the header of the table. Now, alternate solution, those students who hate to write the table. Alternate solution is you have to show step 1, you write the equation y is equal to y1 f prime times dx, which is, that's what, and you have to start with here 1 plus what you have here is you are writing in the equation, like, and then you draw the line and then you say step 2, you begin again, y is equal to y1 plus f prime time dx. So you have to show the two equations separate, and that will give you, I prefer that you show the table, but it's up to you. My students are always using the table and they get it because this concept is not so difficult. Okay guys, so we have some more practice problems on. I explained the two examples. I would like you all to check the answer key posted in the classroom. I'm trying to make the shorter video here. So just one thing I would like to show you here. This is 2005 APBC 4 example. You are going backward. You start with a 0, but you have to go to negative f of. So that's the only piece here I would like to show you, that this is, you start at 0 and you are going at negative 0.4. So your dx is negative 0.2. So x, y, dy is equal to 2x minus y times negative 0.2, and this is your new y. This is your new y. I hope this helped. I'm giving you the answer. I highly recommend that you pause the video here and you do this, finish this example and check that if you get this answer. Now I have used a calculator to get this answer. So let's not simplify and answer you are writing in terms of something plus something minus something. So what will be this answer is 1.2 plus negative, this is starting with 0, 1, negative 0.2, negative 0.4. So 0 negative 4 minus 1.2 times negative 0.2. And that will be the answer. Okay, student, I just realized that your question looks different than this video. So you might want to change it. Please watch the second video where I'm going over a couple of more examples. The second video is going to be a very shorter one where I'm going to walk through certain hints how to do those. So make sure you watch the second video. Thank you.